OH functional group, carboxyl groups, C double bond C. You studied those things in a chemistry, but you ever wondered how you can measure those things? You can find those things. This is the technique. This is the functional group analysis technique in which you can identify this presence of those bonds. Here it is also like a for it is also like a fingerprint. For a certain hydroxyl bonding, there will be a peak at certain positions. And when you go for higher studies, you will study detail about that. But I will give you some basic understanding about this. Morphological characterization. Morphology is nothing but a surface of a material. It is the surface of my material. It is analyzed by using a SEM analysis, which is a scanning electron microscope. You know about the cameras where you use a photon as a light source, but here we used to take same photographs by using an electron source. It is very interesting where you can go in depth, you can penetrate the surface of a material, or not a penetration, you can explore the surface of the material by using the electron source, and they capture the photographs of this material. It's not a photographs, it will be a electrographs, because photographs in which the photons will involved, here the electrons are involved. It is basically the picture of material. You can see this picture by SEM analysis, which is a scanning electron microscope. And more in-depth morphology will be studied in a transmission electron microscope, where you can see a very interesting things. You can explore the nanometer, the material with the nano size also. Here you can see the patterns, which is almost 0.2 nanometers, which you can explore, which is a lattice pattern. It is an arrangement of, you know about the crystals. You used to say that there is a huge amount of atoms arranged together in a regular periodic way, or in a uniform way. Did you ever wondered? You can see that here. You can see that there is a lines. These lines are nothing but the electrons in this lattice pattern, where the electrons are arranged together. In this TEM analysis, that is a HR TEM analysis, you can easily see those things. It's a beautiful one. And here you can see the deposition of copper nanoparticles on the surface of bismuth titanate metal oxide, which I used here. It is not an easy thing to see those nanoparticles, but in a HRTM you can see that. And elemental analysis, it is a EDAX analysis. It gives information about the elements present in your material, and so you can confirm that you got what you expected to get and what you try to synthesize. UVDR spectra. For a photocatalytic material, we should understand how it absorbs light, and so we have to analyze its optical property, like light absorbing property. To understand that light absorbing property, there is a several techniques, but we used UV visible diffuse reflectance spectroscopy technique. In this spectroscopy technique, it gives the information about how much of the light it material get absorbed. Here it's a wavelength. We are inciding the light from the wavelength of 200 to 700 nanometers, and you can see that the light has absorbed highly in the UV region and little bit in visible region. It means our material can absorb the light in visible region. And it is the tau plot which is extracted from this graph, with the relation between alpha h nu and photon energy. It gives the band gap energy of the material. Did you ever wonder how we used to measure the band gap energy of the material? This is the way. By using the optical property of the material, you can find the band gap edge of band gap of a material. Like a zinc oxide, for zinc oxide you will study in a 3.2 or something like that. Did you ever wondered how people measured, how people in scientific community measured that? It is the technique for that. By using a tau plot, you can measure the band gap energy of a certain semiconductor materials. Photocatalytic evolution. We study the photocatalytic property of the material where it clearly shows that after 90 minutes of degradation process, almost 100% of this molecule got degraded. This graph is nothing but it shows the concentration of organic pollutants in our reaction solution, and it shows amount of pollutants left during the degradation reaction process. And after 90 minutes, we can see the 90% of those organic molecules got degraded. It's a trapping experiment and it's a photocatalytic mechanism. It is how it is happening inside, how electron is excited from the valency band to conduction band, how those trapping of electron is happening inside. Everything can be explained by using this. It is very interesting. You need to know about the basic things like how electrons get excited from the valence band to conduction band. But here I will teach you a little bit, overall things for that to get involved in the involved is it will be like a basic research class for your future. Here you can see the valence band of bismuth titanate oxide um, and conduction band of bismuth titanate, where we can measure this by using a normal hydrogen electrode. There is a formula to measure these things based on its band gap energy. And you can see that when light falls on the falls on the photogalactic material, the electrons will transfer to the conduction band. These electrons will get trapped on the surface of copper nanoparticles as well as graphene sheets, and so these trapped electrons will undergo reduction process and oxidation process to degrade the organic molecule. This is the very basic thing here to understand. Our ongoing and future works, we are trying to optimize our nanocomposite to produce a high efficient materials. We are trying to study the photocatalytic mechanism more detailedly, and we are trying to construct a material which can absorb huge amount of solar energy. We are trying to understand the formation of intermediates during the degradation process also, and we are trying to discover new synthesis strategies. And so if we can find a new synthesis strategies, it will be very easy for industrial people to produce more amount of catalysts and this amount like materials with very low cost. And conclusion, here is a conclusion. The current work is in current research work. This is only a part of research work which we did, and we successfully synthesized the ternary nanocomposite, and we analyzed with that various techniques like UVDRS, HRTEM, and we used model organic pollutants like rhodamine B, tetracycline, and we try to deduct how our material is degrading those organic pollutants to clean the water resources. Yeah, these are the some of my research articles. These are the research articles are published in international journals, and it will be very interesting for you if you can have a time to look on this. It will be very interesting. I think I wrote some articles with very basic things, and so you can easily understand. Yeah, these are the some of the articles. You can get the list from Mr. Narayanan if you want to listen to this.
Yes, sir.
Yeah, thank you.
Yes,
Thank you so much.
Okay, dear audience, if any queries from this session, please ask to sir.
Very, very nice and
Yes. Okay, carry on.
very, very nice and impressive presentation.
Thank you. Thank you.
Dear audience, if any queries from this session, please
Here
ask.
is speak in Rajasthan. Here is speak from Rajasthan.
I want audience to get clear what are the doubts they have regarding to research on everything to find. I think we can use this session. We can use something like a 10 minutes more to discuss about how we can get opportunities to do some research in future, how to get a positions for a PhD, for a master's, in Europe, UK, in UK, US, something like that. In a huge, there is a huge opportunities are there. You have to explore those things. Now I think majority of you people are from undergraduate. You have a huge opportunity. You can use that in very positive way. I hope so. You will be very happy with my presentation. Yeah, if you have any doubt, you can ask me.
Sir, I am postgraduate,
Yeah.
but now jobless.
Any other
I
questions?
want a good job.
Yeah, you can try by sending an emails to the professor who are doing research in your field. That is the only way. In addition to that, there are some funding opportunities will be available in several websites. You can find there, and the most efficient way will be by using by sending an email to the professor who works in your field. But definitely you will get that. In recent times, in last 2 3 months, it is very hard due to this COVID situation, but now you can try, you will get that. You should have a good quality of your research history, like a good quality publications, and so you can get a position with in a good research institutions for sure. Yeah.
Thank you, sir. This session is very useful
If
for me.
any other queries, dear audience?
Sir, please
Feel free to ask
about
questions. Feel free to ask questions. Yeah. If there is any, feel free. I'm just like you. I just finished my bachelor's on 2015 and my master's on 2017. I am also very new in this research field, and you can ask me questions if you have any doubt. No worries on that. Don't need to hesitate about anything.
Okay.
sir, please tell about some physics field jobs.
Um, I don't know anything about specific because physics is a ocean of science because you can get a jobs in several industries, education institutions, and R&D sections. If you want to do some more physics related jobs which you can explore morely, you should go for a R&D in each and every industries. For an example, like metal processing industries or oil processing, crude oil processing industries, and other several industries like how to instrumentation manufacturing and designing industries. You can get job there easily. It's a wide field. I did my PhD, everything in a Department of Physics, and now I am working in a Department of Chemistry because it is highly interdisciplinary. I found many people working on the biology also because you can explore many things. You have to select your own field, then you can approach higher studies on that, and so you will get a very good position. The most important thing is the competition here. You have to grow your, you have to develop your resume or curriculum in a very positive way when you have a time, when you are young, and when you have a huge amount of free time. Once you do that, the opportunity will you will get the opportunity very easily.
Okay.
Sir, our university is more student. Our university is more students passed by last 5 year paper solved. he always not now a good physics,
Mm.
but all are one job. It is very difficult.
Yeah, it's very difficult, but we have to overcome these things. You can send me an email regarding to if you have any other doubt. You can send me an email. That will be fine.
Okay, sir. Thank you, sir.
Yeah.
And dear audience, any queries from this session? Please ask to sir. Okay, sir. Thank you so much for your wonderful webinar. Really, I am so happy right now because of your given the best and wonderful and motivation talk also. Okay, in the slide is many creativity things is there. Really, so we are very happy. Thank you so much for your given
Yeah,
wonderful
Mr. Shano.
talk. Yes, yes. Yes, sir. Ram, sir, you can start, sir.
Very
Yes.
thank you, sir.
What? I can't hear you clearly.
Very thank you, sir.
Thank you so much. Thank you so much. Thank you so much.
Thank you.
Yeah, Shano. Thank you so much, and yes, we enjoyed your webinar. Shano. Yeah. Cool.
Okay, sir. Thank you so much, sir. Thank you so much.
Yeah. Thank you.
Okay, okay, thank you, sir. Nice meet you, sir. Thank you.
Thank you, sir.
Th-
Super, sir.
Thank you.
Thank you all.
Thank you, sir.
Thank you, sir. Thank you, sir. Super, sir. Program.